Welcome everybody. Today is the second video of this week. In the first video, we did a little bit of introduction of the course. We look at such a relation of three numbers ABC, a squared plus b squared equals c squared. We call such a triple ABC a Pythagoras triple if these three numbers are governed by this relation. Okay, so this video will look at the geometric side of such a Pythagoras triple. So the first thing I'm going to do is here. I'm going to divide the factor c squared out in each of the term of this equation. In that case, you'll arrive at the equation the square of a over c plus the square of b over c is exactly equal to 1. Why is such an equation important? Because I hope you can recall something in high school that the equation x squared plus y squared equals 1 is exactly the equation of the unit circle with the center 0, and the radius 1 here. So during the course, we'll simplify the notation a little bit and call such a circle unit circle here. And please go back to the original equation we're talking about. Can you notice something here? If you think of a over c and b over c as the x coordinates and the y coordinates of a point on the xy plane, and because of the fact that we already have this relation that the square of a over c plus the square of b over c equals 1, this point in the xy plane must be a point lying on the circle x squared plus y squared equals 1, and that's exactly the geometric side of this equation. So now let's do a couple of examples here. The first one, we look at 3, 4, 5 as the Pythagoras triple, the three values of ABC here, and we did exactly the same trick as before, that we divide the factor c out. In this case, the factor c is exactly 5. We divide it out in the first two numbers. We get the point 3 over 5 and 4 over 5 on the xy plane. And obviously, this point must be a point lying on the unit circle we talk about. And again, let me do a brief summary here. Now the fact is that if you have a point ABC as a Pythagoras triple, you do the following simple trick that you divide factor c out in the first two numbers, and this point must be a point lying on the circle. And the equation of this circle is x squared plus y squared equals 1. And to put it in the other way, we can say that the point a over c, b over c is actually a rational point on the circle. I call it rational because a over c, which is a fraction, b over c is again a fraction, and these two numbers are rational numbers, so we call such a point a rational point on the circle. So now the original question I posted last time, how to find Pythagoras triple ABC constructively, this question is now essentially the same as this following question, that how to find rational points on the circle with the equation x squared plus y squared equals 1. And as I mentioned before, that's exactly the geometric side I want to talk about. So the numerical side, how to find the Pythagoras triple ABC, can be converted into the geometric problem, how to find the rational points x squared plus y squared plus 1. X squared plus y squared equals 1. And in that case, now it basically means that we can look at the geometry of the circle x squared plus y squared equals 1 and try to locate the rational points up there. And it's going to solve our original question in the black color, how to find the Pythagoras triple. So in the next video, we'll try to do this exercise of finding the rational points on the unit circle pretty easily and in an interesting way. In the final part of this video, I want to look back to the non-primitive triple recorded in the last video. We talked about that if we see a triple ABC which has common multiple bigger than 1, like 6, 8, 10, which has the common multiple 2. In that case, we call it a non-primitive triple. And in this case, we try to use the geometric method we did today. So what happens? You can see the following. So now you divide the factor c, which is 10, out in the first two numbers. You'll get the two numbers 6 over 10 and 8 over 10 here. And in that case, such a point obviously is exactly the same as the point 3 over 5 and 4 over 5. So which basically means that We are really looking at the same point as the point we looked at for the triple 345, which is a primitive triple. So as I emphasized in the last class, we don't look at non-primitive triple. There's a geometric reason behind, based on the materials in today's class, that because if you do this method geometrically, we are actually looking at the same rational point, 3 over 5 and 4 over 5 on the circle x squared plus y squared equals 1. So that is one of the reasons why we don't look at the non-primitive triple, because it doesn't give us anything essentially different. And that's the end of this video. Thank you everybody.